Equations of motion. In this lecture, we're going to use some math in order to figure out the characteristics of the way in which things move. Our focus today is to introduce and use the 4 nifty equations of motion. Now, to be honest, this is a joke from Hewitt. You're the guy who wrote your text. And you'll see 4 nifty equations of motion. Altogether, he calls this the FNEOMs, and so I'm going to stick with the joke. The 4 nifty equations of motion to explore the characteristics of bodies in motion. Now, to be honest, there's 4 formulas, and these math equations are used to calculate the motion of all kinds of things, not only from balls falling from high places, but the characteristics of cars, human beings, especially when they do things like jump, rocket ships, the moon, the sun, the universe, the galaxy is all governed by these 4 basic equations. And so FNEOM number 1 says that displacement equals velocity initial times time plus 1/2 acceleration times time squared. This by far is the most common formula that we use. You use it about 60% of the time. It's not the only one though. FNEOM number 2 says that displacement equals 1/2 the quantity velocity final plus velocity initial, that whole quantity times t. FNEOM number 3 is velocity final equals velocity initial plus acceleration times time. And FNEOM number 4 says velocity final squared equals velocity initial squared plus 2 times acceleration times displacement. To be honest, if you really pay attention, this formula and this formula are both kind of the acceleration formula rewritten in interesting ways. Just as a matter of convention, in phase class, I'm going to try and write all the information that deals with the y-axis in this blue color. The whole point is, once we start talking about y-ness and x-ness, it can get confusing really, really fast. And any information concerning the x-axis, I'm going to draw in red. There are 5 aspects to the equation of motion. And the first one is displacement, usually represented by this d. And basically, this is how far a body, and just for your information, in physics, the body is a special name for an object. But displacement is how far a body is moved. There's 2 types of velocity. Velocity initial is how fast a body is moving in the beginning. Velocity final is how fast a body is moving at the end. And then acceleration is the body speeding up? Is the body slowing down, or is the body at a constant velocity? There's kind of a special case in acceleration, and that's gravity. If it is falling down on this planet, we can call that acceleration g, which stands for gravity, which equals negative 9.8 meters per second squared. The last aspect is time, and that's how long did it take the body to change velocities or move the distance or accelerate. Now out of these 4 are special. Displacement, both of the velocities and accelerations, they're vectors. And so we usually use a plus sign to indicate that the object is going forward, the direction it's facing, or a negative sign to indicate that the object is going backwards. But once I start talking about the y-axis, and if a body is falling, if I were to jump out of the bushes and point, okay guys, up or down, which way is positive? 99% of the population is going to say a positive is indication of up. A negative is an indication of down. So we're going to hang on to that convention. Okay, so what can we do with these equations? Now, this video went viral a couple years ago, and it is a parkour athlete doing some really crazy things. By the way, do not try this at home. Okay, I know it looks fun, but oh my gosh, it's so dangerous. But could I actually think of this in a physics perspective? How far did this athlete actually end up falling? And what's cool is we can take this YouTube clip And with a little more information, we can start using these FNEOM equations to answer this question. So I've revisited the clip, but I've added something to it. So here we go. He runs, but I've thrown a timer in here, and I see that it takes this guy 1.591 seconds to jump from one building to the next. Out of interest, do you have any idea why I put this in blue? Is the guy falling in the y-axis? Yeah, that's why I put it in blue. Well, that's interesting, and we can find that out, but I ask a follow-up question. Now, how fast was this athlete traveling when he hit the pads on the lower building? And to be honest, we can go back to the film and look at it and get the exact same information again. That he leaps, and it takes him 1.591 seconds to get to the other building. So when I ask how far, actually the question is asking about displacement. And when I ask how fast at the pads, actually I'm talking about velocity, and because it's at the pads, it's at this building, that's the final velocity. Well, let's see how it's done. So I suggest before you do any FNEOM problem, let's draw a really quick sketch of what's going on. There's a man, and he's on a tall building, and he leaps to a shorter building. This kind of gives you an opportunity to visualize what's going on and keep all your information straight. Now, I found that the time it took this athlete to fall was 1.591 seconds. And then because he is falling in this direction, I get to apply the acceleration due to gravity, and that is negative 9.8 meters per second squared. Now, I need one more given, but to be honest, I'm going to pause for a little bit. The unknown, the thing that I'm looking for, is the displacement, and that's in the y-axis, and it's blue because it's in the y-axis. The unknown is displacement in the y, and I've added this little subscript y to indicate that it's the y-axis, and that's going to be in meters. At this point, I need to find an equation that deals with time and acceleration and displacement. If I go back to my FNEOMs, you'll see that this one deals with time, displacement, and acceleration, but I need one more element. I need velocity initial. So I'm going to displacement equals velocity initial times time plus 1/2 acceleration times time squared. So I need that velocity initial. Now I call this the Wile E. Coyote effect because now Wile E. Coyote and the Roadrunner is a classic Looney Tunes comic, but actually there's some physics wrapped up in here because this happens to a poor old Wile E. Coyote all the time, that the Roadrunner scares him off the cliff, and for a split second, Wile E. Coyote doesn't move in the air. Now, to be honest, you understand that things begin to fall, but for a split second, everything acts like Wile E. Coyote and hangs there for just a moment. He looks down, and then he starts to accelerate down towards the center of the Earth. Funny, but it has a little bit of physics wrapped up in it. And you know what? Our parkour athlete does the same thing. The split second that he steps off of this edge of the building, he hangs there for just a moment. So his velocity ends up being 0 meters per second. And because it's in the beginning, that's a velocity initial. And I can add that to my givens. And now I'm ready to substitute and solve. So okay, what's displacement? I don't know, so I'm simply going to rewrite that in blue because it's in the y-axis. And displacement equals velocity initial. I found that to be 0 times time, which is 1.591 seconds, plus 1/2. The acceleration due to gravity is negative 9.8. And then the time, which is 1.591 squared. At this point, it becomes an exercise in simplifying what I got. Now, dy I can't simplify, so I'm going to rewrite that here. But this portion right here, I can simplify. What's any number times 0? 0. So even 1,247,000 times 0 is still 0. And so 0 times 1.591 is still 0. In essence, this blows up. I don't need to write it anymore. Okay, can I simplify this? What's negative 9.8? 1/2 of it. Well, if you put that in your handy-dandy calculator, you're going to find that you get a result of negative 4.9. Can I simplify this? 1.591 squared. When you do the math, you get a number 2.531281. Now, can I simplify this? I get a displacement in the y that equals negative 12.403279 meters. Now, I'm not done yet. I'm very, very close. I need to figure out how many significant figures I need here. Now, I know that, oh my gosh, look at this one. This looks like there's only one sig fig. But actually, because it's by definition, this number has infinite significant figures, and so therefore will never contribute to the significant figures of your answer. I know that this looks like it has 2, but actually scientists have found this to about the 6th decimal place, and so that means that this has 7 sig figs, and to be honest, that will never contribute to the significance of your answer. But this number here has 4 sig figs, and that's going to help me determine that my answer is going to need 4 sig figs. And so my answer is going to be negative 12.4. Okay, that 0 is significant. The 3 has an opportunity to round it, but it's not going to 0 meters. Now I want you to stop and think about that number. Is that a really far distance? That's 12 meter sticks. To be honest, that's about the height of a 3-story building. Can you interpret what this number means? First off, it means down because of the negative sign. And 12 meters is really far. This is dangerous. I doubt that you could jump negative 12.4 meters and not have something serious happen to you.